Sakana AI's AI Scientist, which came out just a few months ago, just published its first peer-reviewed paper, and it was accepted. This is a paper that was completely written by AI, researched, tested, and fully published by artificial intelligence. And now it went through the same peer review process as humans. All right, so let's get into it. This is Sakana AI. The AI Scientist generates its first peer-reviewed scientific publication. This paper was generated using the AI Scientist v2. And remember, the AI Scientist is fully open source. You could download this and run it yourself. This is the GitHub repo. It gives you all of the instructions. It gives you a bunch of example papers that it has written. It's really cool. And of course, what did the AI Scientist actually research and publish? Well, how to improve itself. Look at this. Compositional regularization, unexpected obstacles, and enhancing neural network generalization. Now, this is definitely exciting because it is self-improving artificial intelligence. Now, obviously, this is just the very beginning of it, and it's far from perfect, but this shows a glimpse of what can be possible. And of course, I'm going to reference this for like the millionth time, the intelligence explosion. When we reach AGI and AGI is able to do research into improving itself, apply those improvements, and continuously iterate in that loop, all of a sudden we will hit the intelligence explosion. And we're seeing more and more glimpses of what that may look like. All right, and let me remind you how the AI Scientist works. So this is from the original AI Scientist blog post. Initially, the LLM has an idea or a plan for innovation. Then it checks for novelty. Is this new? Has it been discovered? Has it been tested? Then it scores its ideas. So if it has a bunch of ideas, it tries to score them on which one is most practical, useful, etc. Then it comes up with an experiment template. Here is how we're going to test this idea. Then it writes code and it uses an LLM and Aider, AIDER, which I've talked about plenty on this channel. Aider is awesome. And so it codes up the experiment, runs the experiment, iterates on the experiment, tests it, iterates, tests it, so on and so forth over and over again until it comes up with something substantial. It outputs the data, then it writes a manuscript template, then it writes up the text, writes the manuscript, and has another LLM review the paper, and then so on and so forth. And it just does this over and over again until it has a paper of high enough quality. So the AI Scientist v2, after being given a broad topic to conduct research on, generated this paper. The paper reported a negative result, which is interesting, and I'm going to come back to that in a second, that the AI Scientist encountered while trying to innovate on novel regularization methods for training neural networks that can improve their compositional generalization. This manuscript received an average reviewer score of 6.33 at the ICLR workshop, placing it above the average acceptance threshold. Now, let's talk about that negative result. Apparently, a lot of researchers simply will avoid negative results. And what does negative results mean? It just means we tried something and it didn't work. And so researchers obviously want positive results. They want to say, we tried something and it was awesome, it worked, and it provided value. But the negative results are just as important, especially publishing them, because that saves time for the entire scientific community. Okay, that approach didn't work. Good to know. I won't try that. But again, a lot of human researchers try to stay away from anything that may result in a negative result because they just don't think that's as worthwhile. But now, if we can prove the negative results using AI, maybe one, it'll open up more human researchers to be okay publishing negative results. And if not, it'll just give us a bunch of negative results that we can use and try to find the positive result path. But after the review, this AI paper was not treated the same as a normal paper. Let me read a little bit about that. They did not go into this hiding the fact that all of this was done by AI. In fact, they worked with the ICLR directly, telling them, yes, this is all going to be done by AI. So we believe it is important for the scientific community to study the quality of AI-generated research. And one of the best ways to do so is to submit a small sample of it to the same rigorous peer review process we use to assess human-generated science. As earlier mentioned, we conducted this research with the full cooperation of both the ICLR leadership and the organizers of this ICLR workshop. Furthermore, our AI-generated papers will not be made accessible on OpenReview's public forum. This is because for the purpose of this particular experiment, the ICLR conference organizers, workshop organizers, and ourselves have agreed that AI-generated papers will be withdrawn for further consideration and automatically desk rejected after the peer review process has been completed. They are really just testing the waters. They want to make sure it can pass peer review, get through the rigorous peer review process, but they're not quite ready to continue with the post-review process. And you know what else is a really novel idea? The sponsor of today's video, Mammoth. Access the best generative AI for just $10 per month. This includes the best LLMs like Claude, DeepSeek, GPT-4o, Llama models, Mistral, Gemini, Grok, and reasoning models like DeepSeek R1 and O3 Mini. And for that same price, it also includes the best image generation models, Midjourney, Flux Pro, Recraft, DALL-E, Stable Diffusion, all in one place. And you can create custom Mammoths to help you on your projects. These are kind of like agents. And you give them all your custom context and they will know what you need them to do. You can install it on any device, Apple, Android, Windows, Linux. You can do one-click reprompting and so much more. So definitely check out Mammoth. They've been a great partner to this channel. Tell them I sent you, links down below. Now back to the video. But it's not perfect. And not only is it not perfect, there's a couple nuances that should be noted. Number one, we note that while our AI scientist has successfully generated peer-reviewed work, the venue in which the work is presented is at the workshop track, rather than at the main conference track. Now, I didn't know exactly what that meant. Why is it important that it wasn't part of the main track? It was part of this off track. And so let me read you what I found out. So the paper was presented in a workshop track rather than the main conference track. In academic conferences, the main conference track is typically more prestigious, featuring highly selective and rigorously reviewed papers. Workshop tracks, on the other hand, often focused on specialized topics and may have less stringent acceptance criteria. Therefore, presenting in a workshop track suggests that the AI scientist's work, while valuable, may not have met the higher standards required for the main conference track. And they even call it out in the blog post. Workshop papers present preliminary findings that are less refined compared to main conference submissions. So they're not trying to hide anything. They put it all out there and they are innovating and iterating, and all of this stuff is just going to progress faster than we can ever imagine. And so they just clarify one more thing. The main conference track has an acceptance range of 20 to 30%, whereas the workshop track is at 60 to 70% range. And here's another important facet. We also would like to note that the AI scientist is a system based mostly off of state-of-the-art large language models, and thus the performance of the AI scientist is directly tied to the performance of these LLMs. And so the better the LLM, the better the performance. And remember, it's open source, so you can try different models yourself. Maybe you want to try Grok 3 or Claude 3.7 Thinking or GPT 4.5. You can try them all and see which one works best. And the paper made mistakes. It was not perfect. In citing a reference, it cited the wrong reference. And it says right here, Goodfellow et al. 2016, and this should be Hotschreider and Schmidhuber. Sorry if I'm pronouncing that wrong. And this comment should be more precise. And so yeah, there were definitely a few issues with this paper that they needed to correct. And they even said right here, we believe that the papers we sent to the workshop contain interesting, original, though preliminary ideas that can be developed further. And again, even though there's a lot of mistakes, even though it went to the workshop track, even with these things, it is incredibly impressive to me. The AI scientist is discovering new knowledge. I can't stress that enough. And just imagine if we can scale that up, if we can smooth the rough edges of the process of the paper and get better models in here. Every little improvement has an exponential increase on the other side. And so I really think this is a really cool, interesting glimpse into what the future of scientific discovery will be. And so what does the future look like? We believe the next generation of the AI scientist will usher in a new era in science. That AI can generate an entire scientific paper that passes peer review at a top-tier ML workshop conveys very promising early signs of progress. Now, I love that they're focused on ML, machine learning, because as the AI scientist is able to discover new novel techniques, novel discoveries, it can re-implement those to itself and improve exponentially. It is seriously exciting stuff. We expect AI to continue to improve, potentially exponentially. At some point in the future, AI will probably be able to generate papers at and beyond human levels, including at the highest level of scientific publishing. We predict the AI scientists and systems like it will create papers worthy of acceptance not only at top ML conferences, but also in the top journals in science. So you can check out the papers on their GitHub page, and I'll link these down below. So we have the different papers that it's published, the ICLR workshop scores, the Sakana AI human reviewer, the AI reviewer. They also provide the full code to get this working yourself. So you can download it and have your own AI scientist. And if you think only the most cutting edge AI can do this, don't forget, just about a month and a half ago, right when DeepSeek came out, Simon Willison on his blog detailed that he used AI to 2x the speed of DeepSeek. And it was 99% written by AI. Now, we're going to see more and more of this as AI continues to write more of the code in the world, as AI gets more capable in discovering new knowledge, testing theories. We're just going to see this insane explosion of intelligence as predicted by the paper Situational Awareness by Leopold Aschenbrenner. So if you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.